Hello, good morning. We're going to do notes number 2, graphing absolute value functions. Okay, so we're pretty much on our, according to the calendar, second or third day of graphing. You should have watched the video, part 1, part 2 of notes number 1. And you should have also watched the video on assignment number 2 and turned that in as a homework assignment, okay, as a grade. We're going to take, tonight you don't have homework, but you need to make sure that you watch these videos and do the practice problems, okay? Go ahead and put your name, period, date, notes, graphing absolute value functions. Today, your objective is to learn the effects that A, H, and K have on the parent function. You will be able to write an equation from a transformation. So that's our goal for today, is that when you see the description, the verbal description of a transformation, you'd be able to write an equation. And then tomorrow, you're going to practice seeing the transformations and coming up. You're going to see the equation and come up with the transformation. We're going to do both, vice versa, okay? So your warm-up is to kind of refresh your memory. If you have a function that is equal to x squared, which is a quadratic function, okay, this is the parent quadratic function, describe the transformations. So if I have f of x is equal to 2x squared plus 6, what does the 2 in front of the x squared do to the function? Hopefully you guys said it correctly. It is a vertical stretch by a factor of how much? By a factor of 2. Good. And then what does the plus 6 do to the function on the outside? It shifts it up 6 units. Okay, so this is kind of refreshing your memory. This is not new, but this is what we're going to use again. I know maybe you may have forgotten, so we're going to practice that a little bit, okay? If you look at f of x is equal to 1/2 x squared minus 4, come up with the transformation. Okay, after you think about it for a little bit, the 1/2 is smaller than 1. So instead of stretching it, it's going to cut it or compress it. So vertical compression by how much? By a factor of 1/2. Okay, so it's making it shorter, fatter, wider. And it is a vertical shift. This is on the outside of the parentheses, outside of the x squared. So is it going to be vertical shift up or down? It's going to be a vertical shift down 4 units because 4 is negative. Okay, and then the last example of the warm-up is if you have 3 parentheses x minus 2 squared. Well, by now you should be a pro. You know that the 3 on the outside of the function is a vertical stretch or compression. That's correct. It should be a vertical stretch. And then this is actually inside of the parentheses. Anytime you have something inside of the parentheses or inside the absolute value function or something inside, it's going to be the opposite of what you see. So you would think x minus 2 would go to the left, but it's actually moving to the right. So this is a horizontal shift right 2 units. Okay, this is the part that mixes this up the most. So keep that in mind, okay? All right, so our notes, it got smeared, sorry. So this is your parent function, the absolute value of x. The absolute value of x can be transformed by changing the a value, the value in front of the x, the value h, and the value k. Okay, a, b, h, and k just stand for some random number. In this case, a was 2, 1/2, and 3. So a gives you a vertical stretch if a is greater than 1, or it is a compression if A is between 0 and 1. In other words, if it's a fraction. Okay, the letter B in the front, we didn't really see any with a B, but B is a horizontal stretch or compression, but more importantly, the way that we see it here is if it's a reflection over the y-axis. Okay, so B tells you if it's a reflection over the y-axis. It also reminds me that if A is negative, if A is less than 0, then it is a reflection over the x-axis. Okay, I kind of ran out of space. I didn't think I was going to take up so much space. So if I look at H, I'm going to take this out. Okay, so H moves horizontal, shift to the left or to the right. Okay, and then K, as you guys know already, it is a vertical shift either up or down, depending on if K is positive, it goes up. If K is negative, then it goes down. Okay? There are some very cool things come from A, B, H, and K. It tells you what the graph looks like, how it has changed from the original pairing function. The letter H and K give you your vertex. So whatever H and K are, that's going to be your vertex, which is awesome. If you notice, as a recap from the notes that we took yesterday, if you look at, let's say, number 1, H and K, H would be 2 and K would be 0. So the opposite of H is -2, which is -2 here, and then K is 0. So that's your vertex. If you look at number 2, your vertex would be H. There is no H, so it would be 0, comma, and then +2. And if you notice, the vertex is 0, 2. Okay, so now if we look at our notes again, so H and K come from your function. Your slope is actually whatever A is. So if you see a 1/2 in front of the A, or in place of the A, then you know that your slope is up 1 to the right 2. Okay, so let's practice this, okay? Another way that you may see it is A times the function, which just means that we have either a vertical stretch or a vertical compression or a reflection if A is negative. You may also see it as f of b of x. The b stands for this b, so you know that it could be a reflection over the y-axis if b is negative. Okay, you could see it f of x minus h. This is the same thing as that. Okay, all it's saying is to shift the graph to the right or to the left, h units. Or you could see the function plus k. So that's telling you to shift up or down. All right, so if in our guided practice, we're going to do some problems together. When you look at number 1, the value of A is 1, so no big change there. B is 1. H is 5. And K is 0. Okay, the actual value of H is not a +5, it is the opposite of what we see, so it's actually a -5. The only transformation here is a horizontal shift. Which direction? Left or right? It's going to go to the left 5 units. Okay, the vertex is our H and our K. So our vertex is going to be -5, comma, 0. And then your slope is 1. Easy? I think so. Okay, let's look at number 2. A is equal to 1/2. B is equal to 1. H is equal to 0. and then k is equal to 3. So in this case, there's two transformations. A vertical, the A gives you either a vertical stretch or a vertical compression. Is A bigger than 1 or between 0 and 1? It is between 0 and 1, so it is a vertical compression by 1/2. And the K at the end tells you that it is a vertical shift up or down. So vertical shift, in this case, K is positive. Vertical shift up 3 units. Okay, your vertex comes from your H and K. In this case, H is 0 and K is 3. So it's going to be 0, 3 as my vertex, and my slope is whatever A is. So it's up 1 to the right 2. I don't know if I want to write the A's, but anyway, let's look at number 3. Go ahead and do number 3 on your own. Check with your partner, see if you guys have the same answer. Go ahead and do number 4 on your own and check with your partner to see if you have the same answer. I want you to check with your partner sitting on the left and then your partner sitting on the right. If you don't have a partner sitting to the left or right of you, then pick someone in front or behind you. Okay, and then let's look at number 5 as a final one. In this case, A is equal to 5/6, B is equal to 1, H is equal to -1. It's the opposite of what you see here. And then K is equal to -3. So this has a couple of transformations. The first one is a vertical stretch or compression. It should be compression by 5/6. It's also a horizontal shift. Is it left or right? It's going to go to the left, 1. And then it is a vertical shift up or down. In this case, it's down 3 units. Your vertex is HK. So whatever H is and whatever K is. And then finally, your slope would be your A value, which in this case is 5/6. Okay, so we practice going from a function, from an equation, and describing the transformations. Now we're going to go from the transformation and come up with the equation. Okay, so if the absolute value function is reflected over the x-axis, I know that A has to be -1 and is horizontally shifted right 2 units. So H has to be equal to a +2. Okay, so I'm going to say f of x is equal to negative absolute value of x minus 2. It should be a +2, but whenever we have something inside the absolute value, it's the opposite. Okay, the absolute value function is vertically shifted up 5 units. So anytime you see up, you know that that's K. And horizontally shifted left 3 units. So you know that that's H. So I have f of x is equal to the absolute value of x shifted to the left 3 units. So I know H is equal to a -3. We're going to write the opposite of what we see. And then we're going to put +5. Okay, go ahead and try number 8. The absolute value of a function. My bad. Let's do number 8 together. It is stretched by a factor of 2. So that means that A is 2. B reflecting over the y-axis. If it's reflecting over the y-axis, we know that this has to do with B. And then shifted down 1 unit. So that's K. Okay, so your function would be stretched by a factor of 2, so 2 on the outside of the absolute value function. In this case, since it's reflecting over the y-axis, that means that B has to be negative, and it's shifted down 1 unit. Okay, before I run out of time, I want you guys to do number 9 with your partner, and then your turn is to do number 1 through 6 on station 1 and station 3. This is station 1. Go ahead and pause it and take a picture. And this is station 3.